Alright, my little math friends, now we're moving on into chapter 10. We talked about taking a survey of a random sample. Now we're going to actually do something with that data, kind of do a little bit of like a type of graphing and answer some questions about it. We're going to be looking at making an inference, okay? And this is to make a conclusion about a population using results from a random sample. Okay, so we talked about in the last lesson about voters. So if we took a random sample of voters and seen who it is that they would like to pick for a presidential candidate, then we could make a conclusion about the entire population. Alright, it may not be true, but it might give us some indication of what would happen. Alright, so first we're going to look at organizing data from a random sample. So here's a random sample we have here, a group of middle school students. Oh, how about that? You guys are middle school students too. We're asked how many pets they have at home. Below are the answers they provided. Okay, so this many people were asked how many pets they had at home, and here's the numbers they came up with. Alright, the first type of thing that we're going to make is a dot plot. Alright, and you guys might have made this before. So we're going to go through and make one of these again. It might just be a review, but we're going to take all of these numbers here and put them on this number line. Okay, so we're going to number this number line using the numbers we have here. The lowest one is 0, so we're going to start at 0, count up on the number line to our highest number, which is 9. Okay, then we're just going to put some dots where we have all of these numbers at from this survey. Okay, so we get a dot right here at 9, 1 at 2, and I'm just moving down the list. 0, 4, 6. I have 2 3s, so you stack your dots on top of each other. When you have 2 or more at one point, there's another 2. And the last one we have is a 5. Okay, so there's our dot plot. It's just a way to organize the data so we can see kind of what's going on. We can see that most people have about this many pets right here, kind of in the middle. And then we can answer some questions about the data. You guys have probably done this before, so this will be a review. These are 4 things that we'd like to find out about the data that this question was asking. So first of all, what is the mean? That's just the same thing as the average. Okay, and remember with the average, you add and then divide. Okay, add and divide. So if I add up all of these numbers here, that is going to get me 34. And then I have to divide it by how many numbers I have. I have 9 numbers total. So divide by 9, that's going to get me 3.7. But it's kind of hard to have 3.7 pets. I mean, that's kind of a weird number. I don't know who has 3.7 pets. So let's round that to 4 pets. Alright, so on average, the mean is 4 pets in each house. Alright, let's take a look at the median. The median is the middle. Okay, that is our middle number. So what we have to do is we have to line up our numbers from smallest to biggest. Okay, so I'm going to take these numbers, I have some space up here, and I'm going to reorder them. Starting from the smallest, I have 0, and we're just going to put them in order. A 2, another 2, 0, 2, 2. Cross them off. It helps you keep yourself organized. Then we have a 3, a 3, a 4, a 5, a 6, and the last one we have is a 9. Okay, so now to find the one in the middle, now that I got them lined up, you just start crossing one off on each side until you end up with your number in the very middle, which is 3. Okay, so my median is going to be 3 pets. my mode is the one that happens the most. So taking a look at our numbers here, we have two modes. We have a 2 and we have a 3. Those are the numbers that happened the most out of all of them. Okay, so we had 2 pets and 3 pets were our most numbers. What is the range? Okay, the range is the big minus the small. Okay, so my big minus small would be, my biggest number is 9 minus my smallest number 0. Okay, so that gives me 9 as my range. Alright, I went through these ones kind of quickly because this is more of a review. I know you guys have done these before, so we're just going to kind of touch on those a little bit as we move along. So let's take a look at something else we are going to make. And we are going to make something called a box plot. Alright, this one takes a few more steps. You don't have to write these numbers down again. I just did this because we're going to need them for our box plot. Okay, so let's go through the steps to see how we make a box plot. Number one, we're going to organize the data from small to big. Okay, and we already did that before when we did our dot plot, so we already got that step done. So now we're going to move on to step number 2. We're going to find the median. We're also going to find the low, and we're going to find the high. Alright, so the median, we already found that. That's 3. And let me get this number line numbered here too. You guys can do this also. If you haven't got yours numbered yet, let's do this because we're going to need that. Okay, so we got our number line numbered just like we did up above. Now our median, that's the first thing we're finding here. The median we already found, it's 3. So what we do at 3 is you're going to put a line, just a straight line, kind of a thick line right here at 3. Okay? Then we're going to get our low, which is 0. That's the lowest number we have. A dot's going to go right there at 0. Our highest number is 9. A dot's going to go right here at 9. Okay, this is going to make kind of an interesting thing when we're all done here. You guys will see what this turns out to be. Alright, did step 1, step 2. Step number 3, we're going to find the median of each half. Okay, so take a look at our numbers up here. We found the median, the first one, so that divided it into 2 different halves. We got a lower half of numbers and an upper half. Okay, this is going to be our lower and uppers. Okay, so for my lower half of numbers, if we look, our middle number, we actually have 2 numbers in the middle, not just 1, but 2 of them, since we have an even number. Then we're going to have 2 in the middle. Since they're both 2's, our lower median is going to be 2. So I'm going to put a line now at 2, just like we did with the 3. Okay, the medians have the line like that. Now for my uppers, my 2 numbers that are in the middle for the uppers, I can't just pick one. I can't pick 5 or 6 because they're both in the middle. So I have 2 numbers in the middle, and since they're different, we're just going to find the average of those 2. Alright, so we're just going to take 5 plus 6 gets us 11, and then we're going to divide by how many, which is 2. 11 divided by 2 is going to give me 5.5. Okay, so that is my upper median. So I'm going to put a line right there on my upper median. Okay, we got that done. We're moving on to step number 4. We're going to box the medians. Okay, this is where the box plot name comes from. We're going to box these medians. Okay, so we're going to connect a line to these 2 medians, and then a line from the 3 to our other median right there. Okay, so it's going to kind of make a box with these thick lines in the middle and on the end. Okay, so we're boxing up the medians. And then the last part we're going to do, we did number 4. They call these funky little things we're going to put on here. We're going to add the whiskers. Okay, because this little box plot is going to have some whiskers, and that's going to be a line going from the median to our highest number, and a line going from this median to the lowest number. Okay, and we're done. We just made a box plot. It's just another way to show the data. If we're looking at this, we can say, well, most of the pets were right around this range. These numbers were closer together. These ones were kind of spread out a little bit. The median to our highest number, there was quite a gap there. There's a lower gap over here. So it's just some different ways to show how the data kind of came out. Okay, so there's your box plot. And the last thing we're going to do, we're going to jump gears just a little bit here, and we're going to take a look at how we can use something called a proportion. A proportion is just a fraction. Okay, I don't want to freak you guys out with fractions. Okay, we're not going to do anything too crazy with them. We're just going to make some simple fractions here. We're going to use proportions to make an inference. Okay, we're just going to find out some info about a situation. Okay, so take a look at what we have here. A shipment to a warehouse consists of 3,500 MP3 players. Alright, the manager chooses a random sample. Okay, so here's where this random sample thing comes in we were talking about, of 50 MP3 players, and finds that 3 are defective. Okay, so out of the 50 he picked up, he just kind of chose 50. There were 3 of them that were bad, defective. So what he wants to know is how many MP3 players in the shipment are likely to be defective. So based on this information, how many out of the 3,500 are probably going to be defective? Okay, so what we are going to do is, to answer this question, I'm going to show you a little trick here. We're going to set up fractions. Okay, now please don't freak out on me because I use the word fractions. Okay, we're just going to set these up. You guys will see how simple this is. Remember, a fraction is part over a total. Okay, part of something goes over top of all of something. Okay, that's how a fraction is designed. So first let's make a fraction for our sample, the sample that he took, okay, right here. So the total number of the sample was 50 MP3 players, and 3 of them were defective. Okay, so the total number of MP3 players chosen was 50, so that's going to be my total for the fraction, and out of that 50, 3 of them were defective. Okay, so there's my fraction. 3 out of 50 MP3 players defective. Alright, now let's make a fraction for all of them. Okay, so the whole entire thing, which is going to be this number, 3,500. That's the total number of MP3 players we have. 3,500, so that's going to go on the bottom of my fraction for the total. And what I'm trying to find is this number right here. How many of those are going to be defective? Okay, that's what we're going to try and do. So, to do that, we are going to find the multiplier. And what I mean by that is just making equivalent fractions. For example, 1/2 is the same as 4 over 8. Okay, these are just the same fraction. They're both 1/2. They're just written differently. And 1/2 is being multiplied by 4 to get 4 over 8. Okay, so we're just going to set up equivalent fractions. We're going to do the same thing over here. We're going to figure out what the equivalent fraction is for 3 over 50 over here on this side. Alright, so we just have to find the multiplier. Okay, what are we going to multiply 50 by to get 3,500? Alright, so this is where we're going to do some math. To find out what to multiply 50 by to get 3,500, let's just take 3,500 divided by 50. We'll just work it backwards to figure out what that would be. And when you do that, that comes out to 70. So 70 is my multiplier. 50 times 70 gives me 3,500, and because we're making an equivalent fraction, we are also going to multiply 3 by 70 to get this number over here. So 3 times 70 is going to get me 210. Okay, so there's my equivalent fraction. 3 over 50 is the same as 210 over 3,500 when we multiply this fraction by 70. Okay, so this is the number of MP3 players that are likely to be defective. We don't know for sure, but we're just kind of making an inference, making a guess based on what we know. Alright, there is your lesson 10.2, everybody. I'll see you guys next time in class, where we're going to do A, make some dot plots, we're going to do B, we're going to make some box plots, and then C, we're going to be taking a look at making these equivalent fractions to find some inferences. Alright, see you guys next time in class. Thanks for watching. Don't forget to try this question.